All right, beautiful people. So today we are moving into our data and statistics unit. So we are on page 117. If you are in first, second, or seventh hour, ninth graders, we are on page 113. If you're in my sixth hour, because our numbering was a little bit off because I forgot to skip pages. Who'd have thunk? So anyway, we're on the one that it should look like this. It says data and statistics in algebra 1. So our essential question is just going to be looking at data and statistics. So what are the different representations to display data? So most of these are review. Most of these are not difficult. You guys have done stuff with most of these. So it's not a really tricky unit. It's just a unit that we need to touch base on. The appropriate statistics foldable that we are going to do on Wednesday is, well, probably Wednesday. And going off my timeline, things could be different. You never know. But is like the algebra piece of this. Okay, so let's go ahead and jump into dot plots. A dot plot is no more than a number line. So you start with a number line for a dot plot. They've already drawn the number line for us. Okay. And all you're going to do is you're going to use either dots or X's, and you're going to put the number of dots or X's above the line. So first we have to number our number line. So if I look at my data here, the smallest number that I have is a 4. So I'm going to start with a 4 here, and I go all the way up to a 9. So 4, 5, 6, 7, 8, and 9. Okay. So you can see I had to unstaple mine just to fit it all on there. If you have it up here and you need to, here, why don't I just do this? I'll write them on here because I'm going to have to restaple it anyway. There we go. Okay. So now we're just going to count the number of times each number occurs. So that's what this data displays, is the number of times that data point occurs. And we're, for this one, looking at the average number of hours of sleep they get each night, which I'm probably down here at like the 4 right now if Goose is here. So for number 4, for 4 hours, we have 1, 2, and that is it. So I'm going to draw 2 little X's or dots. I like X's better. I don't know. They just are easier for my brain. Who knew? Why not? I don't know. Okay, 5s. I have 1, 2, 3, 4, 5. 5 5s. 1, 2, 3, 4, 5. Now we want to try to space them out the same. I know it seems silly, but I want these two to be kind of level so that my scale actually looks good, right? If I space these two X's out way far away, then it's not going to be as easy to glance at it and see the data. 6s, 1, 2, 3, 4, 5, and 6, and 7. So 1, 2, 3, 4, 5, 6, 7. I have 1, 2, 3 7s, and 1, 2 8s, and 1 9. There's a college student getting 9 hours of sleep. Holy smokes. Okay. So I like to just double check. There should be 20 X's because that's how many students they sampled. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's really easy to miss a number. Okay, even when you're crossing them out, which I should have said, but I always like to cross them out because the odds are then I'm less likely to miss a number. Okay, but there is that data. So the most important part of this foldable is not actually creating them. You guys have been creating dot and most of these different types of graphs probably since like 3rd or 4th grade for this one. Okay, but it's why we use which one that is important. So we're going to jump down to this overview and vocabulary tab. It's the very last tab. You can see here that they use dots. I use X's. They mean the same thing. Okay, but really we want to make sure we understand why we would use a certain one. So a dot plot, okay, is used to display data. And we're looking at the frequency, so how frequent something happens. Because if you look at this, I can see that this, whatever point it is, has more, or like on our dot plot that we just did up here, I can see that the majority of college students get 6 hours average a night. Okay, so that's how frequent each one happens. And then we can also see the distribution of the data. So I can see that the lower amount of sleep number and the higher amount, sorry, a little bit of nose, the higher amount and lower amount of sleep on my dot plot here, stuck to my paper, it's less frequent, right? So you can tell that here, these are your more frequent hours. So we use dot plot to see the frequency and distribution. Other things that we can find in our dot plot are our mean, median, mode, which we will review what they are in just a few minutes when we get to box plots. We can find our minimum and our maximum here, minimum, maximum, and we can also see different types of trends. We would not want to use a dot plot if we had like 500 people surveyed, right? Because that would be a lot of dots or a lot of X's on there. So we generally use dot plots if it's a little bit smaller amount of data, okay? All right, jumping to, we're not going to do the second example of most of these. We're just going to do one, okay? Just to keep time moving quickly because most of this should be review. Okay, jumping to histograms. Histograms are very similar to bar graphs, which again, you've been doing for quite some time. Okay, the difference mainly between a histogram and a bar graph is that a histogram, you don't have spaces in between your bars, and we're looking at a range of data. And I'll kind of explain what that means in just a minute. So it says the time in minutes it took members of the cross-country team to run their 5-kilometer race are listed below. Oh, man. So for this, it's not just a number line. It's an XY. Whoops. It's an XY coordinate plane. It's, on this case, only an L because we're looking at time and frequency. So with bar graphs, you might have like color up here color down here and numbers, or you might have like categories down here and a category up here. Whereas with histograms, we're really looking at frequency. So we're seeing how often it's happening. So on a histogram, my y-axis is going to be frequency. How frequent something is happening. Okay, it's going to be frequency. And then in this case, what we're looking at how frequent it happens, I'm just going to set this aside for a minute. It's in my way. Okay, in this case, we're looking at time in minutes. So my x-axis is time, and we want to specify that it's in minutes. It's not MD running this in 23 hours, because that's probably what it would take me right now. I'm doing these over spring break, so Goose is still in the belly, sucking the life out of me. So I would not be running anything right now. Anyway, squirrel or parasite. So what we want to do here is notice I'm not going to list every single time because then the frequency would be the same. If I just did the frequency of a person that got 23 minutes and 47 seconds, that'd be 1 because none of these are exactly the same time. Okay, or at least I don't think so. I didn't actually study that, but I don't think they are. So what I want to do is I want to put ranges here. Okay. So this is always 0. You can use a break if you need to, but in this case, I don't think. Well, yeah, we will need to because we don't start. Let's see my lowest time here. Looks my lowest time here is this 1802. Is that true? Yes. So 18 would be my lowest. So we can use our break. Remember, we can draw 2 lines. That is telling the reader of our graph, okay, that we are skipping a section of numbers and we are acknowledging that we're skipping that section of numbers. Okay, so our lowest is 18 here. And I need to go all the way up to 2907. So round it to probably an even. So my sections here need to be the same spread. I can't go 18 to 20 and then 20 to 25. That doesn't work. Okay, because then you're skewing your data. And the thing with data and statistics is that it's really easy to skew that data. That's why we have to be careful when we're looking at commercials or different data graphs on different things, that we understand that I can skew data to be however I want my data to be. So keeping that in mind, when we're trying to create these, we want to try to show the data as it is, not skew it. So, oh my goodness, I'm sorry. So I think here I'm going to count by twos. So 18 to 20, 20 to 22, 22 to 24, 24 to 26, and 26, 28. Shoot, I'm going to have to add one. That's okay. We're going to add our line, and we're going to try to space it as best as I can. We're going to add 30. Okay. I just like working with twos. I think it's the easiest in this case. For you guys, that's probably the hardest part, is figuring out what scale to use down here. I just looked at my data. I knew that I had, my lowest was 18, my highest was 2907, and then the number of lines that I had. The nice part when you're making your own graph is you can not have to add lines. You can make it as big as you want, okay? So now for our frequency, we're just counting by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, the other thing that we have to make a decision of is where we put certain numbers. And in this case, it's not really going to matter for most of our data. But let's say we had a data point that was exactly 18 minutes. We would need to decide, or that's not a good example because 18 isn't an end cap, but let's say it was exactly 20 minutes. We would need to decide if we're going to count 20 in the previous one or if 20 is going to go in the next one. We can't put it in both. Okay, well, we could, but then again, you're skewing your data a little bit. So we only want to count that frequency once. So like we have this 25 here, that's exactly 25. It doesn't really matter because it falls in the middle of my section right here, so it won't impact us. But if it was one of our end, we would just need to make the decision and be consistent with that decision. So if you're going to put 20 in the 18 to 20 range, then 26 would have to go in the 24 to 26 range. Okay, you just got to be consistent. So now we're going to count how many are in between the 18-minute and 20-minute range. So that means if it's 18 flat all the way up to 19 and 59 seconds. Okay, almost said 99 seconds. That's not how time works, MD. So 18 to 20 here. Okay, so we're going to count. And again, I'm going to cross them out because that's going to help me. I have one here. I'm looking for 18 to 20. Okay, so 1, 2, 3, 4, 5. That one's over 20. So it looks like 5. So to be appropriately correct, we should use a ruler. Okay, and I'm going to draw my little line here. So 18 to 20, I'm looking at 5. Don't have a ruler. It's the end of the world. Just trying to show you good habits. Okay, so from 18 to 20, we have 5 numbers that are there. That's the frequency of that. Okay. Then we are looking at 20 to 22. So anything above 20 and less than 22. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, is that how many? Did I miss one? Oh, 20, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice I used a different type of crossing out. I only used one line. That's just so I can go back and easily, especially if I get distracted, which you guys know me, I do very often. So it looks like I have 10. So I'm going to go up to 10. And I'm going to draw a line here at 10. Uh-oh, I went past it. That's okay. We'll just use a little whiteout. That's why I probably should be using pencil, but that's okay. There we go. Perfection. Okay, so then we're doing 22 to 24. So, one. Wait, no, that was over 24. This one. 1, 2, 3, 4, 5, 6. Do I have 6? Yes, I have 6. Okay. So we're here. We're at 6. That one was easier because it matched up. I still went too far. That's okay. Okay. 24 to 26. 1, 2, 3, 4, 5. So that one should be even with this one. Again. Ooh, that one I did perfect. Nice job. Okay. 26 to 28. I'm trying to think of what other circle underline. 1, 2, 3. 3 little guys. Okay. And lastly, 28 to 30 is just this guy right here, which would again be more likely to be me. I made that bar a little too big, but that's okay. So there you go. There's your histogram. So no spaces in between bars. That makes it a bar graph. Our y-axis is frequency, or how often that section is coming. And we're not just counting by ones here, because usually our data, we can't do that. So even on, if you look at example 4, even on these, we would want them to be, gosh, my brain is not thinking of the right word. Like sections, a group of numbers, not just counting by ones like we did on our dot plot, okay? So overview for histograms. This is when we would use histograms. Okay, a histogram is used to show a group of data values that are closely grouped. So we wouldn't want to use a histogram if we, let's say we were talking about like ages of the people, like all people on campus, including teachers. You would have a huge range because you would have your student population, right? Which still is a decent range. What probably goes from like 12, is that how old our 7th graders are, up to like 18. So we could use that. But then you have a huge gap until you get to all these teachers that are all spread out. So we wouldn't want to do a histogram because then you're going to have a gap in your data and it's going to be spread really weird. Okay. With no outliers. So quick review of what an outlier is. An outlier is the MD of the number world, right? It's something that doesn't fit into the trend. So we talked about outliers when we talked about scatter plots, okay? It does not fit the trend. So just be careful, because if I have data that looks like this and a number out there, that's technically not an outlier because it's fitting in the trend, versus data that looks like this with this outlier over here. It does not fit that trend or your line of best fit, okay? We'll calculate actual outliers here soon. We use what's called the mean. The mean is another word for the average. We add them all up and divide by the number that there are to show the center. And this gets into our appropriate statistics that we'll talk a little bit more about as the week goes on. Okay, the middle of the data. And then we use what is called the standard deviation. Okay, the standard deviation to show the spread, because we don't want outliers. So essentially, standard deviation is like how far away from the mean data points are, kind of like the MAD, kind of, but not really. And again, we're going to talk more about those two things when we get to appropriate statistics. One more thing we need to talk about is actual distribution and the shape of a graph. So when you look at this guy is just kind of a flat line. But when you look at this graph, you can kind of see this little curve, right? So this is what we call symmetric. It's a symmetric graph. Is that how you spell symmetric? Sure, we're going with it. Okay, it's a symmetric graph. And then we have skewed graphs. So notice this one, okay, is skewed. So it looks like it's going steps downwards. So this is what we call skewed. And specifically, this one is skewed to the right. So your highest point is skewed to the right. Okay. Then we obviously have skewed to the left. So we can let's draw that one up here just to make sure that we have that one written. So if I have this guy, okay, this guy is pretty similar, but obviously it's going to be going stairs going up. So we're going this way, okay, and this one is skewed to the left, okay. So you're going to need to know that when it comes time for like envision stuff, this skewing, and it has to do with the distribution of the data, okay? So we have histograms. All right, we're going to do one more today, and we're going to look at box and whisker plots or box plots, okay? So these are also, I should change colors. These are also called box and whisker, which is probably how you were taught them, or box plots. So be careful, dot plot versus box plot. Dot plot has dots, or in our case, X's. The box plot has a box, okay? The box plot is definitely the hardest one, in my opinion, okay? In the sense of you have to find the most information in order to do it. Okay, and I'm going to show you how to do it on Desmos. But here we go. So box and whisker plot. So, or a box plot. So the reason that it's called a box and whisker plot is because it literally has a box and then two lines coming from the box that someone named whiskers. Okay? So, in order to do a box and whisker plot, we need to calculate what is called the 5-number summary. The 5-number summary. So these are the 5 things that go on a box and whisker plot. We need the minimum. smallest number. Okay, we need what is called quartile 1, which is the middle of the lower half of your data. Okay, we need the median, or the middle. We need the quartile 3. The reason that it's quartile 3, not 2, is because your median can also be called quartile 2. Your quartile 3 is the median of the upper half of your data, okay, and then your maximum. So we're gonna calculate this by hand for this one, because it's good to know how to do it by hand, but then then we can do it on Desmos afterwards, okay? So this is how this works. Their minimum is pretty simplistic. It's your smallest. Now, before we do all of this, though, the first thing we should do is put them in order from least to greatest. Okay, so I have 13, 20, let's see, 24, nope, 23, 2 23s, then 24, then 2 27s, 2 30s, I wrote them kind of close, 2 34s, and a 55. So again, quick check, 1 2 3 4 5 6 7 8 9 10 11 12, 1 2 3 4 5 6 7 8 9 10 11 12. Perfect. Okay, so you want to put them in order from least to greatest. So your minimum, I think, is pretty simplistic. It's your smallest one. Okay, so your minimum is your smallest. Your maximum is your largest. I think those are the two easiest. Okay, then we can find our median, which is the middle. And again, you can't do that if they're not in order. So my middle here, 1 2 3, 1 2 3, 1 2, we're just crossing out. So if you notice here, my middle is 27. Now, notice I drew my own 27, because technically neither one of those 27s is actually the middle. It's this 27. Let's say this was 26, this was 27, then my middle would be 26.5. Okay, so that's my median. And then the two that are the little bit harder ones are your quartiles. So your quartiles are finding your middle of your lowest portion and your middle of your highest. So for quartile 1, we're looking at this section, okay, including this number here. Okay, sorry, not including that number there. My bad, not including that number, because that number is our middle number. Okay, so we're going to cross 1 2, 1 2, and so again, it's in the middle of these 23s, so it's its own 23. I'm going to show you how to do this on Desmos, but by hand it looks like this. Okay, and then lastly, my other is this side here. Okay, so we're at 1 2, 1 2. So my middle is in between 30 and 34, which happens to be 32. So that's my quartile 3. Okay, so again, it's the middle of the two sections. So now I just plot them. So I'm going to estimate 13 is a little bit more than halfway. So we draw a dot there at the end. My quartile 1 is at 23. So right there, we're going to draw a dot. My median is at 27. Dot. My quartile 3 is at 32. And my maximum is at 55. So we're going to draw our box and whisker. So we draw the box in the middle 3. And we draw a line down here, and then we draw our whiskers off the other 2. Dang, look how straight that line is. Way to be. Okay, so it should look like this. It's a box with whiskers. Your box goes around your 3. Normally we label here. Okay, so this is your minimum. Okay, quartile 1, Q1, because I'm lazy. Your median is literally your middle. And then we have quartile 3 and your maximum. Just so you know what each one is. Okay? Now, here is the most craziest, confusing part about a box and whisker plot. Okay? What you need to understand is that each section here actually houses the same percent of your data. So I would hope that you understand that between your minimum and your median, which is your middle, there is 50% of your data. That's why it's called the middle. Okay, versus this guy is your medium and your maximum, which is another 50% of your data. Okay, that means that each section here between each 2 dots actually houses 25% of the data. So this is 25%, this is 25%, this is 25%, and this is 25%. Now, the reason that it looks different and it looks more spread out, so it doesn't actually seem accurate, is because that tells you that between the quartile 3 and the maximum, your data is a lot more spread out, which makes sense, right? If I look between 32 and 55, that's a lot more spread out than 23 and 27. So we can't let our eyes fool us. It's not necessarily telling us that we have more numbers between my quartile 3 and my maximum. We actually have the same amount of data points between quartile 3 and maximum as we do between the median and the quartile 3. The difference is that between the quartile 3 and the maximum, the data is a lot more spread out. So the length of the box, the length of the whiskers, don't necessarily have anything to do with the number of data points that are in that section. It has to do with how spread out the data is in that section. Okay? So, that's important to know. We also have this sixth, I can count. Sixth number that's important when it comes to calculating outliers, which again we're going to talk about. But it's called the interquartile range, or the IQR. Now, it's not necessarily stated on here, but the interquartile range is your quartile 3 minus your quartile 1. Okay? So in this case, my IQR would be 32 minus 23, okay, which obviously, hopefully, is 9. Okay? That's, again, not going to come in super handy yet, but since we just talked about quartiles, I wanted to show you that. Okay? So let's go ahead and look at when we use this, our overview of box and whisker plots here on our last page. Of this I pulled it off. Okay, so here we go. We use a box plot to show a set of data that are spread out. So unlike a histogram, we could use a box plot for data that's spread out, because you just saw on the last one, okay, it doesn't really matter how spread out the data is. We can still show the data, okay? In this case, we use the median, or the middle, to show the center, whereas on histograms we use the mean, okay? And we use what is called the interquartile range, which we just talked about. Oh, there's an N in range. That's an N. Okay, to show the spread. So it shows how spread out the data is, okay? On here, our 5 data sets are our min, our quartile 1, our median, our quartile 3, and our maximum. Okay, and then my IQR is found by doing quartile 3 minus quartile 1. And lastly, the most important thing in my opinion that you're going to get asked a lot is that there's 25% of the data between all of my sections, even when it doesn't look like it. There will always be 50% of my data between the median and the maximum and the minimum and the median. Okay, no matter how skewed my data looks. Again, the length of the whisker or the length of the box strictly tells us how spread out the data is, not that there is more data points in between there. Okay? Okay. Okay, let's actually go ahead and finish two-way frequency real quick, because that's our last one. And then we could be done with this foldable. So, two-way frequency tables. You guys did an entire unit on two-way frequency tables in 8th grade math. Basically, it shows frequency of two things. Okay, in this case, Jenny surveyed 100 of her classmates on hair and eye color. So it doesn't label it, but I'm guessing these are hair because that'd be creepy to have red eyes. Okay, and these are eye color. So it shows two different, what we call qualitative, meaning non-numeric categories. So we don't use this if we're talking about like age necessarily. Okay, we use these when they're qualitative, meaning they're categories that we can put like these. Essentially, we want to make sure that they total all the things here. So if this is 18 and this is 9 and they're a total of 28, then to get that number, we're going to add 18 and 9, which is 27, which means there has to be one person that has blue eyes and red hair. Okay, and that parasite might be one of them because that's what we're looking at genetically. So this should total this way and it should also total this way. So then we have to, it's kind of like Sudoku, however the crap you say that. Okay, we have to find which one works. So I can now find the red here because we have this total. So 1 and 5 is 6, which means that hazel and red hair has to have 6. 9 and 23 plus this guy equals 48. So when I do that math, again, I'm going through this kind of quickly, but it's 16. Now I can start filling in other gaps. Okay, this total, she surveyed 100 classmates, so this should be 100. Okay, that makes this one 41 because 28 plus 41 plus 31 is 100. And then we can go this way. So this number plus 23 plus 5 has to be 41. That's 13. This number plus 16 plus 6 has to be 31, which is 9. I could make you do the math, but I'm not going to. Okay, and then easy 18, 13, and 9 make 40. So it's like I said, it's like filling in a puzzle. That is two-way frequency. Then we have what is called relative frequency. Okay, relative frequency. Relative frequency is a percentage. Okay, it's a percentage. So we're going to make our own little table real quick. We're going to do blue, brown, hazel, and total. And we're literally going to make our own table. Again, I'm not spending forever on this. This is an 8th grade standard. And you guys are not going to see a ton of these. And then we have blonde, which I'm pretty sure blonde has an E at the end, but maybe it's a different way to spell blonde. Brunette. Red. And total. So if we're looking, wow, I made those lines extra long. I'll give you a second just to finish that. Okay, so with the relative frequency table, we want them out of percentages. So my total of my totals should always be 100%. Okay? I want to know what percentage of that each section here is. So what we do is we take our total, which again is 100, and we're dividing each number in the box by 100 and then multiplying by 100 to turn it into a percentage. So we take 18 divided by 100 and multiply by 100 to get our percentage. Now, the nice thing about this table is that it's out of 100. So all of my percentages are actually going to be the exact same number, just with a percent sign, because it is a percentage. Okay. Let's say that I had surveyed 300 people, then it's not going to be as pretty because it would be 18 divided by 300 times 100, which is not going to be as simplistic. But the percentage, we can just write, all of these are percentages, okay? Because they are out of 100, it's just that simplistic. And then what's important to know is they still should total. So 28 plus 41 plus 31% should be 100%. So if it wasn't out of 100%, these numbers should still total to be that 100%. Because again, let's say if it was out of 300, then this guy would be 300 divided by 300 times 100, which is still 100%. Okay? So relative frequency is as a percentage. So let's look at an overview here. Again, I'm not too concerned about this part, but you can see here, okay, that 2, 6, 5, and 2 make 15. 15 and 17 make 32, so you're just doing that. Joint frequency is just the inside of your table, so you can kind of see here it's marked. It's this section right here that is not in your total section. And then your marginal frequency is the totals, essentially. Okay, so your marginal frequency is this guy. You're not going to see most of those, but there you go. Okay. We use two-way frequency tables again when we're looking at two qualitative categories. Two categories like hair color and eye color, or gender and favorite subject, or type of car and a I don't know, gender. Okay, whatever it is. So those are our main types of graphs. Okay, they're the main types of displays of data that you guys are going to see. It's this last overview in vocab is important that you guys note that. Put this nicely back in here. Okay, and then we will continue to look moving forward on calculating. Oh my gosh, my brain is not working. Calculating outliers, okay, as well as continuing to talk about when we would use each one of these, as well as looking at does well. So we still got a little bit to go. That'll get you guys started. I hope you have a great rest of your day. Goodbye, beautiful people.